Hello, I'm Whitney Lee. I'm a technical advocate, and this is
Abby. Excited to say hello. I am a principal engineer at Syntasso.
Abby and I just spent over an hour and a half talking about custom resources. In the comments, we'll put a link to that longer conversation. But meanwhile, here we are making a recap video. Personally, I'm interested in what you think of this, Abby. Personally, I'd say a custom resource, if you want to extend your Kubernetes cluster by adding custom resources, then you need to add a custom resource definition that teaches your Kube API about the custom resource. So then that enables you to be able to make the actual custom resources that are specific to that particular instance of the custom resource. But it's very likely that you also want there to be running stuff somewhere, infrastructure things. In order for that to happen, you need a controller. In most cases, we'll say, and we'll talk about the exception, the recipe is you make a custom resource definition to teach your Kube API about your custom resource. And then when you actually create an instance of the custom resource, the controller has the logic that does the work that makes that custom resource run on your cluster. But let's talk about it in a little more detail. You're nodding yes, so that's good. You would tell me if I was wrong, right?
I would absolutely tell you. That all sounds right.
Okay, cool. Do you want to start us off about what we talked about first?
The first thing we wanted to do was actually demystify custom resources and custom resource definitions by looking at how they're just Kubernetes resources. So what is a Kubernetes resource? We talked about the fact that a Kubernetes resource definition is a schema that is stored in etcd. And so this is just kind of YAML definition, a schema that says what required fields are there, what optional fields are there, what validation on those fields can be applied.
If this is installed as part of your Kubernetes cluster, so therefore you don't ever think about it. Like a Kubernetes cluster by default knows when you say you want to make a pod resource, it knows what to do. And that's because the pod resource definition has already been created and stored in the cluster.
Then, I guess, Whitney, what is special or different about a custom resource definition?
Oh, I love this. A custom resource definition is not installed as part of the Kubernetes cluster. So whatever the custom resource is you want to make, Kubernetes API doesn't know about it yet. So you need to install the custom resource definition, which, spoiler alert, is just a schema. Then that teaches your Kube API to accept this new kind of resource, this custom resource.
Exactly. And you don't have to always write those custom yourself, though, right? Like there are ways to get custom resources that have been written for you. Yes?
Yes. So as we talked about, there are two types of CRDs. So you might have already interacted with custom resources because you added Prometheus to your cluster. You added Knative to your cluster. You use like Cert Manager. Those are all adding custom resources to your cluster. But maybe there's something you want to do and you can make your own custom resources. So it can go both ways.
Exactly.
So I like this teacher-student thing. Keep asking me questions.
Okay. So you talked about this thing, an instance of a custom resource definition. Tell me more. What is an instance of a custom resource definition?
A custom resource is an instance of a custom resource definition. A pod is an instance of a Kubernetes resource, a pod Kubernetes resource definition. But when we say pod in this case, we're talking about pod just being a configuration file that's stored in etcd. We're not yet talking about the actual running pod. And this is what was really confusing for me, is because basically a custom resource definition is a definition of the custom resource. A custom resource is also a definition, but it's a definition of a specific instance of a custom resource. But because they're ultimately both definitions, that's, I think, the crux of why all of this was so confusing for me.
Right at the beginning, when you tried to summarize an hour and a half brilliantly in about 30 seconds, you said that it's most common that you're going to have a custom resource definition and a controller, so that when you install a custom resource that meets that definition, the controller can run some logic and create some things in the cluster.
Do its thing.
Do its thing. Exactly.
Yeah.
That isn't required, though. And we can see that that's not required because we can see how a config map operates in Kubernetes. So a config map is a Kubernetes resource type. And so there is a Kubernetes resource definition that is installed on creation of the cluster. It already knows about what a config map is. Now, as users, we can create config maps that meet that schema definition. And those would be a resource that resource doesn't actually have anything running behind it. It's literally just data in a database, right? It's in the etcd database. And so there actually isn't a controller behind that. It just has the data stored in etcd. So when you go and you say kubectl get config map, it goes to etcd and gets the data out of that without needing to go through any sort of a reconciliation loop.
For the config map, you can make lots of different config maps from one resource definition. Like you taught, Kubernetes knows what it is, and therefore you can make lots of instances of it.
So what would be different about something like a pod? And a pod, at the end of the day, is a container running on a virtual machine, or a number of containers running on a virtual machine, or on a machine, could be hardware. So how does the same setup, where all you're doing is defining some definition that meets a schema, result in a running container for a pod and not result in running infrastructure for a config map? It's because for a pod, there's also a controller that reads that definition out of etcd and takes action on it. And so the controller will read the definition of your pod resource, so your specific resource, not the generic schema definition, and it will try and reconcile that to make it real. And that means setting up some RBAC rules and setting up some networking rules and actually taking a container and running it on the machine.
So this is another place that's confusing for me, or that was confusing for me, because we're saying a pod is the actual definition of the pod stored in etcd. That's a pod. Like before it's created, we're saying the pod is created because it's defined in etcd. And so if we're calling this configuration file a pod and the actual running thing a pod, then that's another area of confusion, because those two different concepts both have the same name and kind of are talked about interchangeably.
And that's because there's this declare and converge idea in Kubernetes. You declare what state you'd like, and that's an etcd, so that's the pod definition. And then Kubernetes will use the controllers to converge that into reality. So whenever you're doing kubectl get and trying to see the status of something, you are checking the status as etcd knows it. It is working on converging that status to reality at all times.
So a controller, it's its own piece of software that's running on the cluster somewhere. And it takes in a resource from the Kube API. So this resource could be a Kubernetes resource, or it can be a custom resource that you created. And then it does its thing. And what its thing is can vary drastically depending on what it is that you're creating. And then it will return a status to Kube API. And what makes a controller special is that it does this on a reconciliation loop, and it can watch the state of things to make sure the state that you defined using your instance of a definition is making sure that state is always as things actually are in the cluster. So controllers was watching that to make sure it's what happens. Controllers are the magic behind Kubernetes itself. So we talked about how the process works in more vanilla Kubernetes resources. And so now for a custom resource, you would first install a CRD. So whether you're installing the custom resource definition that you yourself made, or whether you're installing a third-party one, it doesn't matter. But the first step needs to be you need to teach the Kube API that you want to start using a resource that has this particular shape to it. And then once that CRD is created, then you have the power to make a custom resource. That's where you could actually define an instance of the custom resource that you want to make that's specific, where you define exactly what you want your particular version of it to look like. I would like to say at this point that our Kube API, part of what it means to teach the Kube API to accept this resource is part of the intake process is it's going to make sure your resource when you create it matches that schema, and it's going to reject it from the cluster if it doesn't match that schema. So then once you've created your resource, you've defined the state you want your resource to be and your actual custom resource, your instance of a custom resource, then that's when our controller kicks in and does the actual work of making the running instance of the whatever. When it does its thing and makes the running instance of the stuff.
Yep. I think that's as far as we got in 90 minutes yesterday. So yes.
Do you have anything you want to add or say around custom resources themselves? Because this is really the meat of why we're here and what it took us a while to figure out yesterday.
I think the only thing I'd say is that the reason we're using the phrases does its thing and stuff that it creates is because it can, right now, it's really popularizing the fact that it really is quite broad, and you can do things in the cluster, so you can create other cluster resources like pods and deployments and things, or you can do things off the cluster, and it's just running software.
Yeah.
So you can do things like configure cloud resources that are not within Kubernetes or any other kind of API-driven infrastructure. So just to call out why we're using thing and stuff, and why there's such power behind that. So yeah.
So then my next question was, I hear operator all the time, and when people define an operator to me, I've never really understood what makes it different than custom resources, and you helped clarify that for me in a big way.
So an operator is another controller that listens to custom resource types that it has defined. But when people in common everyday language say operator, it is typically the package of things required to make that happen, which usually includes other things like RBAC, so role-based access control, and other tools you may need to really make that controller powerful, and the CRDs associated with it and so on. Reason why you might use the term operator as well, aside from just that idea of packaging together all the kind of bits you need, is because you might be speaking about the lifecycle management of something. So that operator operates, creates, reads, updates, and deletes a running application, and it codifies that upgrade process, it codifies that deprecation process, and it can do that for just a single running instance, or it can do that for all running instances of a certain type. So for example, you might have many Promethei running, and the Prometheus operator can manage the lifecycle of all of those. Or you might have a really custom operator just for your business application that has codified all of the create, read, update, and delete, and particularly the upgrade, as I said, process for that really specific application codified in it. So it can be very broad, and it can be also very specific.
So to summarize what you just said, there are two things. And one is the operator wraps up controllers, custom resource definitions with some additional dependencies into one unit. And then the second thing it does is it does application lifecycle management on that unit. That's what makes an operator different.
All operators would contain controllers, but not all controllers will be considered an operator. Exactly, yeah. But again, some people will be very adamant that these are very different, a controller and operator are very different, and some people will be adamant that they're both just running software that run in the control loop. But there are some reasons why we use the both language.
Please do give your kind and constructive feedback and opinion in the comments. We'd love to hear from you for sure. So then we did a good amount of talking about admission controllers, but I have a confession, Abby. I don't understand what the admission controller story has to do with the custom resource story. So let's open with that.
I think that the reason I think of them in similar trains of thought is because both are talking about how to build your custom business logic, your custom needs on top of Kubernetes default behavior. If you want to extend the Kubernetes default behavior by introducing a whole new resource type, you would want to talk about a custom resource definition. If you want to extend the Kubernetes default behavior by putting more business rules around it, so things around when people can access things, who can access, and what are sort of baseline configuration requirements for a built-in Kubernetes resource type, then you'd want to be talking about admission controllers. So you're right, they are different use cases, and they could be completely kept separate, but the reason that I always think about them in the same breath is because there are two implementations of the same intention, which is to build your company and your personal opinions and needs into the Kubernetes API.
That helps a lot. Thank you. So admission controller is part of the Kubernetes API's admission process. So when you talk to the Kube API and you say, I want to make a new whatever instance of my custom resource, the Kube API is going to say, who are you? Are you allowed to do this? It's going to validate your custom resource against the schema that you gave for the custom resource definition. And then it gets to admission controllers as part of the admission process. So the admission controllers can be two different types, or they could be both types at once, I understand. This is another thing that's confusing for me. Admission controller, it's called a controller, but When we talked about a controller before, we said a really important of the controller is that reconciliation loop. A mission controller does not have a reconciliation loop. It behaves more like a webhook. And sometimes you'll hear people call these admission webhooks. In fact, terms are used interchangeably. And weirdly, I think controller is the more correct term, but controller is also the more misnomer of a term, in my opinion. That's another number 3 super confusing thing that got cleared up for me as part of this conversation. Part of the admission process before storing the resource in etcd, that's the final goal of this whole admission process. 2 different things can happen. There can be a validating admission controller, there can be a mutating admission controller, or there could be both. So the validating admission controller, its only job is to be like, is this allowed? Yes or no. And so you can give it lots of different rules. You can give it more complex schema validation. You can give it permission rules. You could say there has to be a compute limit defined, or don't let it in, which I guess is schema validation.
That might not be a required field in the schema, but it might be a required field for your company. I think the really powerful thing to call out is that it can use external APIs to do some of that validation. So not only can you like kind of locally validate the thing, but if you want to check the configuration against something that's out external, you can make external API calls, get data back, and then have that validation happen. So this helps you if you have certain like databases of information that you need to reference on each admission of a resource type.
And then we have mutating admission controllers or mutating webhooks. And that can edit the resource entirely before it gets stored in etcd. So with a mutating admission controller, you gave an example where it might add labels. And I gave an example when I've heard of it before is a way to inject a sidecar in the case of service mesh. You'd use a mutating admission controller to do that. And I think that's everything on the board. So if you want to add custom resources to your cluster, whether it's a third-party custom resource or whether you're making your own, the first thing you need to do is add a custom resource definition, which is nothing but a schema. But what that's doing is teaching your Kube API instance that you have this type of resource. Then once you have that schema, you can make the actual resource. And depending on the resource, probably you also need a controller in place that's going to take that instance of the resource that you've defined in your custom resource, and it's going to make it into infrastructure things that are actually running somewhere.
Just as simple as that, Whitney. How'd that take us an hour and a half, you know? Just as simple as that.
Thank you so much, everyone, for your time, and appreciate you. Appreciate you, Abby. Bye.